Hello, my name is Joseph Budu, and I would like to take you through IT research or IS research. At the end of the whole program, you should have a research paper in hand which you can publish at either a conference or send to a journal. And I'm sure it will be a very important achievement in your academic or professional life. Research is a very nice way of adding to your CV to show that you have done some rigorous scientific research, which you can even apply to your work as a professional in industry or as an academic. So, this is the first episode, which is the introduction to research. And this episode will cover the following topics: what is research, types of research, why do research, introduction to IT or IS research, how to do research, how to write research, and then some basic research and writing tools that will help you in your study or in writing the research paper. So, as I said, by the end of this lesson, we should be able to, for this lesson, in this episode, we should be able to identify relevant research related challenges that we can study for our research paper, and we should be able to apply knowledge in behavioral or design science to solve real world problems of ICT design and use. So we'll take the first topic: what is research? When you are doing research, it means that you are striving to understand existing facts about a phenomenon. So if you take an issue about, let's say, profits in business, what are the various connecting components that can make a company make profits? You want to understand, is it their customers, is it their products, is it their strategy, is it their entire business model? These components will help you to explain or understand how companies make profits. So you want to understand these facts so that you can put them together and say that now I understand why companies make profits. And this endeavor is systematic, meaning that it's not ad hoc. You don't get up one day and just say that I want to understand how companies make profits. Then you go about asking companies, do you make profits? If you make profits, why do you make profit? And then they just give you the responses. That may be a very low kind of research, but if you want to do pure academic or scientific research, you have to go systematically. And so we'll see later on the procedure or the processes that academic research must go through in order to be scientific. And research, the steps and the techniques that we use to achieve scientific research is what we refer to as research methods. So there are different research methods that we will learn about in this program. If you do research, you should end up with an understanding or an explanation of a phenomenon. If you take profit, for instance, it's a phenomenon. How can we explain profit making? Okay, so if you study profits, for instance, your research should come up with an explanation that when A, B, and C combine at this time and under this condition, profits will occur. Other times, research can also result in an artifact, a physical artifact. Let's say a robot, a software, a certain hardware, or an entire system that will help to achieve or, or achieve a certain objective. So these are the two main outputs of research: an explanation or an understanding of a phenomenon, or a physical artifact that we can use to achieve or solve a problem. So when you say a phenomenon in research, this is a word we'll be using very often. When you say a phenomenon, we are referring to a set of behaviors that some entities find interesting. So if you come to IS research, information systems research, or information technology research, we are interested in the combination or the use of computing technologies, hardware, software, networks to achieve a certain human purpose. If you go to physics, they may be interested in the physical properties of bodies or the environment around us. They may not be necessarily interested in computers. If you go to economics, they are interested in how to manage scarce resources to achieve the optimum level of objectives or to meet human need at the optimal level. So different communities and different disciplines have different phenomena that they study. Okay, for us in IT and IS research, we're interested in solving human problems using ICT or explaining how ICTs can help to mediate a certain human behavior. So, and after understanding your phenomenon, what comes out is that you are able to say that because of A, B, C, and D, we can predict that if we bring IT into a certain space, this is what will happen. So that would be an understanding or an explanation of the phenomenon. So we'll take the next topic, types of research. The definitions I've given earlier suggest two types of research that we can do in IT and IS research. The first type is called the natural science research. For natural science research, we aim at understanding a reality or phenomenon in our natural world. We want to explain what are the processes and the procedures and the reasons why organisms related to ICT do what they do and the outcomes that occur when we use ICTs in our space. The second type is design science research. For design science research, this is normally for people in ICT and computer science discipline. Natural science is for those doing information systems or management information systems, typically. So, design science research identifies a real world problem and develops an artifact to solve that problem. Recently, I was speaking to one of my students, and he was working for a regulatory body that had built data centers for all banks in a certain country, the rural banks in a certain country. And the rural banks identified that the data center, shared data center they were using was not quite profitable. So they contracted this man to build private ones for them. And over time, they have seen that these private data centers are fetching them more than when they were using the shared data centers. So he identified the problem of low profitability because of the data centers, built new ones for them, which is a solution, and now they are earning more profits. Okay, so we identify real world problems and then create solutions for them. This, for instance, is an agricultural robot for spraying and sowing seeds on a farm. So this is a summary of the expectations between natural science and design science research. Natural science research is also known as basic research. Design science is also known as applied research. For natural science research, it's aimed normally at descriptive or describing and explaining phenomena, whilst design science prescribes and creates artifacts. So if there was a problem and someone develops a solution, that solution is a prescription of how he or she thinks the solution or how he or she thinks the problem should be solved. It doesn't mean that solution is perfect. He is prescribing a solution to the problem he or she has identified. And then it's a creative process. Coming up with the solution to the problem is creative. Natural science also seeks to understand reality, and normally It produces theories, laws, knowledge, and principles, while design science results in constructs, models, methods, and implementations. Then natural science aims at discovering and generating or proposing a general scientific claim. For instance, we can have a law. One of the laws of thermodynamics is that everything that goes up must come down. Another law in physics is that to every action there is an equal reaction. For instance, this is a general scientific claim. But design science researchers are interested in building. We can use these general principles or scientific claims to build an artifact, like the law of gravity was used to build or help to build airplanes and shuttles. They have to, with the understand having the understanding that there's a force that pulls a body towards it or towards the earth. They had to understand that if you want something to float in the air or fly in the sky, you need to give that thing some power that is more than the force of gravity, so that when it goes up, it wouldn't come down. It will continue going until it reaches space where gravity doesn't work. Okay, so natural science research and design science research are complementary. Natural science also justifies its claims by doing some empirical testing with data to show that truly the claims are generalizable or they work in most contexts or most spaces. And design science research, after building an artifact, also evaluates the artifact to find out the extent to which the artifact solved the problem it's intended to solve. So, why do we do research? For students, we do research typically to show or demonstrate that we understand the various subjects we have undertaken in our degrees. We've done some systems analysis, we've done some e-commerce, IT security, and organizational behavior. So, how do the principles that you gathered from all these courses help you to explain why a certain technology can help an organization achieve profits, for instance? Okay, so your research will show that you understand the various principles and how they are linked together. When you do research, it also shows, for those in ICT, for instance, it helps to show that you understand how ICTs should be designed. You have to follow some human centered design principles or some human computer interaction principles. You cannot have poor contrast, for instance, when you between text and your background. All these are principles that you, when you incorporate into your design, we see that truly you understand the principles of ICT design. It also shows how you use your analytical skills to tackle real world problems beyond the so-called theory we learn in the classroom. You're able to apply this theory to solve real world problems. It also shows your ability to apply theory to solve a research problem. This is for those in information systems. So for instance, you can explain how or the factors that would inform a group of people or an individual to use a certain new technology. So there's a theory called the technology acceptance model, for instance. You can use that model. I don't advise you to use that model anyway because it is quite simple and newer ones have come. But I'm just using it as an illustration that someone can use the technology acceptance model or TAM to explain how or to identify the factors that will make people use mobile money or Internet of Things, for instance. Okay. And Generally, doing research is an academic problem solving exercise. It's a partial requirement for the award of your degrees. So, in our context, this is why we do research. Others in academic institutions who are not students, like lecturers like myself, have to do research to gain promotion. You are identifying or creating new knowledge which will enhance human lives. You are explaining phenomena in ways that humans have never thought about before. So if you are able to bring up such new explanations or create new solutions to existing problems or new problems, you are seen to be advancing knowledge amongst human beings. So you'll be rewarded with promotion, sometimes contracts, sometimes research grants from other institutions or even government. Okay, so these are the reasons why we do research. So if we take a deeper introduction to IS or IT research, we have seen already that research helps to solve problems or to explain existing issues that we do not understand about phenomena. So IT or IS research aims at improving our understanding of the interaction between human beings and information systems. You can take an ERP and its users. Why is it that some ERP implementation in organizations fail whilst others succeed? Why? So someone can look for the factors or mechanisms that cause ERP implementations to fail whilst others succeed. So you'd have explained or improved our understanding about this phenomenon. Also, IS and IT research is important because human beings are increasingly using technologies to achieve biological needs or environmental needs. Human beings want to communicate with each other, for instance. Imagine that you want to speak to somebody hundreds of miles away from your location. Previously, you have to board a vehicle or use token drums or send somebody. But now with mobile phones, we can you can call that person all around the world and have your communication or deliver your message. So information systems are being developed day in day out to support human activities. And so if you take IS research, you want to understand or study how these technologies are designed, how they are used, and how they impact on human activities. And those who do IT research also study, design, and develop these new ICTs. Okay, so that's the main difference. IS researchers study the design. How has this system been designed? How is it helping? What is the impact? Why are people using it or why are people not using it? These are the areas around IS research. And IT researchers study how new artifacts can be designed or developed. And then when they implement these new technologies, they also evaluate to justify the solution and to check whether the solution is really solving the problem. So we want to look at how to do the research, be it IS or IT research. If you want to do research, you need a topic or an area idea that you want to study about. So I gave an example earlier about somebody who develops data centers. This is an area that he is interested in. Okay, you may not be interested in data centers. You want to do smart cities or smart houses. Somebody wants to do Internet of Things. So these are areas we that we can develop new solutions for or explain. So ask yourself, what human activities interest you that you want to study? Is it efficiency? Is it profit? Is it productivity? Is it human well-being or health? These are human activities that you can consider studying in the context of ICT. So we have organizational level issues, human or individual level issues, even national level issues or global issues like hunger. Hunger is a global issue as well as a national issue. Okay, so you identify what issue you want to study. You can download my handbook on research, and there are various prompts in it. When you answer these prompts, it will guide you to identify or choose your topic all the way to finishing the research. Okay, so you can go to www.researchcoa.ch www.researchcoa.ch. If you put it together, you have research coach, but there's a dot between the COA and the CH. When you go to that site, you just register and you have the entire ultimate research handbook sent to your email address, or you can also download from the website. So these slides are tailored to the workbook. You answer the prompt in it and it can guide you to do your own research. Now, when you identify the human activity you are interested in, you ask yourself, is this an activity that can be affected by information technology or by an information system? So if you talk about money laundering, for instance, or fraud, banking fraud, this is something that is happening right now. Can we use information technology to mediate it, to either stop the fraud or fraudulent activities, or to even prevent it? So I know a friend of mine who has developed a machine learning system that gathers SMS messages, and using machine learning, the system can detect whether a certain message is heading towards defrauding the other party or not. If the message is found to be fraudulent, the network operator is immediately informed to take legal action or even to disconnect this person who is sending fraudulent messages. Okay, so here he has used machine learning, which is an IC. He has developed a machine learning based artifact to prevent fraud using mobile money or mobile phones. Okay, so the difference between IS and IT in this at this stage is that if you are doing IS, you should be studying something that is already happening. So in this case, you can study assuming that the my friend's machine learning algorithm has already been implemented. You can now explain how you can explain even how he developed it. You can also seek to understand how he implemented it or how the mobile network and the users are using it. So that's use. And you can also study the impact the algorithm is having on preventing mobile money fraud. So that's for IS. Is the system is in use right now? The system should be in use. The phenomenon you want to study in relation to IS should be happening, should be current, something current happening, or maybe in the past. It could have happened in the past, and you can study what happened in the past to explain what happened. But for ICT, the solution should not be existent. You are now coming to create this new system to solve the problem that you are identifying or an opportunity that you think will come up in the future. Okay, so this is the main difference between IS and IT concerning human activities and information technologies. So with this in mind, there are some questions you should ask yourself. You have identified a topic area that you want to study, you want to explain or develop a new solution for. But ask yourself, is it relevant? Is a topic of relevance? If you are talking about, let's say, a topic about human trafficking is a big deal in our world. Okay, so it is relevant. Maybe you want to develop a system that can monitor or prevent human trafficking. It is relevant. Let's say you want to design a system that can help human beings to communicate with aliens. Is it relevant? Well, to you, maybe. To some extent, it may not be relevant. Okay, because there are so many challenges around us which we haven't finished solving, other than wanting to speak to aliens. Then ask yourself whether it is academically and intellectually interesting to you and others in the IS field. It's not everything that may be interesting to you, and the topic needs to be interesting because it shouldn't be boring. So that over the 8 months or so that you will be doing the study, you will not feel bored and you will not be demotivated not to finish. Okay, so it has to be interesting to you, and of it should it's you may also have to consider your supervisor. Sometimes you send a topic to your supervisor and he's not interested. That one is a human matter that you have to deal with. So normally you can look for your supervisor's list of research topics, issues that he has been researching about. You can check for his research articles or even his dissertation, and you will have a fair idea of the topic areas that he's interested in. You can also ask, please, are you working on any topic? Is there a problem around it that I can work on so that you will have some synchrony with your supervisor? You are not required, not all supervisors do that. But if you identify some conflict, it will be nice to do that so that you save yourself. You want to finish the study and graduate so you can move on to other things. So you can do that. You should also ask yourself, is it interesting? Is it intriguing? When you talk about the topic, do people want to read? E-learning, it may be relevant, but it sounds quite outdated. The factors that affect people's adoption of mobile phones. Well, it sounds relevant, but it sounds outdated also. It's no more interesting. But speak about blockchain, using blockchain to solve corruption in Ghana. That is interesting and that is also relevant. Okay. And ask yourself whether it presents a challenge to sustain your motivation throughout the research project or the duration of the project. I link that to it being interesting. Also ask yourself, is it feasible? In relation to the example I gave about creating a system to communicate with aliens, for instance, when you finish that, how will you test it? How will you have access to aliens to find out or to test whether your system works or not? You see, so it's a nice idea, but it's not feasible. And then, in terms of your ability to operationalize the system, you want to work on blockchain, develop a blockchain technology, but you don't know how to develop a system in blockchain or using blockchain. You are only familiar with PHP and Java, which may not be enough to work on a blockchain system. Okay, so you should also watch your skills and your resources available in order to ensure that you can finish the study. You cannot develop a new ERP in 4 months, for instance. Okay, so you watch your resources and compare to the task ahead. Practically, you should also ask yourself, especially for information systems researchers, whether you will have access to data to test your new understanding. We've said that for IS research, you are interested in explaining or understanding a phenomenon. After understanding it, you should provide some evidence. So, are there people you can interview? Are there people you can observe or run a survey so that they can give you information about the phenomenon you want to study? In relating to the example about using machine learning to prevent fraud, for instance, let's say that algorithm has been implemented. You are looking for network operators to give you insights about whether the algorithm is solving mobile money fraud or not. And then you go and no network operator wants to speak to you, they tell you that this is a security issue. You see, you not have any evidence. So at the back of your mind, you should be sure that you have access to do some interviews, observations, some meetings, some focus group discussions, and some workshops before you set off to do your research. Especially, this is especially for IS researchers. Now, you should also have the process in mind. How can you start doing your research? There are three main ways of three main processes for doing research, but we'll talk about two for now. The first one is called induction, or the inductive approach to reasoning. So, assuming that you wanted to study the factors that affect mobile money fraud, for instance, for if you are doing induction, you literally, or let's say, close your mind to all previous knowledge about fraudulent activities and their related factors. Then you go to the field to have real world observations to find out from people who have faced fraud, who have suffered fraud, and you ask them what do they think caused their caused them to suffer fraud. If you have access to people who perpetrate fraud, you can also ask them why do you engage in fraud. So you get these responses, and out of these responses, you create a framework or an explanation of why fraud occurs from the perspective of the fraudsters and from the perspective of the fraud victims. Okay, so you start from real world observations of the phenomena to the explanations you want to achieve of the phenomena. The other side or the other type of doing research is deduction. Deduction. In deduction, you identify what previous researchers have said about why fraud occurs. So maybe there's a theory of fraud. A theory of fraud may say that when a fraudster identifies a vulnerable person, he gets in contact with him or her, makes a proposal which is not true, makes a false proposal, and if the victim is in agreement with the proposal, he exchanges value, but he doesn't get anything in return, and fraud would have occurred. So this may be a theory of fraud. Based on this theory of fraud, which is here as the theoretical framework, you create a proposition or a hypothesis. You formulate a hypothesis that mobile money fraud occurs when fraudsters identify vulnerable mobile phone users. You see, so the theory of fraud was broad. It wasn't specifically for mobile phone fraud. It was generally for fraud. But you are coming to test it in a mobile money context, okay, to identify whether truly the argument of the fraud theory holds also in mobile phone fraud. Out of that, you test your conclusion by using empirical data. You go and collect data. You go and ask people. Normally in deduction, you need a very large sample size, say 100, 200, and over, depending on your population. You identify a number of people and you ask them questions. I think I was defrauded because I was vulnerable. I think the fraudster found a weakness in my attitude. That is why I was defrauded. So you ask questions and they give you responses. The majority that gives you a particular response suggests that that hypothesis you have formulated is true or holds true. Okay, so out of that, you have your final conclusion. So, in summary, deduction begins from existing theory or knowledge from research. You formulate hypothesis, you collect data to test your new hypothesis, and then it will be a new conclusion. But for induction, you you go to the field to look for evidence which you would put together to create a new model or a new theory from scratch. So these are two papers that one uses deduction and one uses induction. Okay, and so you can see what they do in their respective papers. Quickly, let's look at IT research processes. So IT research, we mentioned earlier, that's design science research. And design science research goes through these steps. First, you have to show how you became aware of the problem. You can do some interviews, do a survey to find out what people think about the situation and how problematic it is. When you understand the problem and all its parts or components, you suggest a solution or you make a proposal about the design or solution you want to implement. After the suggestion, you actually do the development of the artifact. After development, you evaluate to see whether the solution really solved the problem. After your evaluation, you draw conclusion whether the solution is a good one to the problem or not. Okay. If it is, why? Why does this really solve the problem? If it doesn't, what do you think? Why do you think it doesn't solve the problem? So when you are doing research, you have to document it. All research has to be documented. If you are doing your dissertation, you will produce a research report which is in chapters, typically 5 chapters or 6 chapters. But we said earlier that we are working on a research paper, maybe 15 pages to 20 pages. Okay. So whether you're having a dissertation report or a research paper, you will have a research problem. The research problem is the undesirable condition that you want to solve with your research. So maybe there's a problem that nobody has solved. Arguably, nobody has solved using ICT. Let's say mobile money fraud is a problem that has to be solved. That's your research problem. For IS research, you have to show that previous people have still not addressed that problem. So you have to look at previous literature, go into mobile money usage or mobile money literature and show that person A, B, C, and D have studied these topics. Maybe they've studied the adoption of mobile money, the use of mobile money, the impact of mobile money. But to date, no one has studied how to prevent mobile money fraud. Okay. So the assumption from these three papers is that mobile money is smooth and is everybody is using it legitimately. That's the assumption if people have studied use, impact, and adoption. But you are challenging the assumption to show that no, there's a problem. People misuse it. People use it for fraudulent means. Okay, and so there has to be a solution to that problem of fraud in mobile money usage. So you present previous research and then you show the limitation in those previous research. Then you advance or propose that this is an issue that has to be studied so that we can advance our understanding or have a better solution to the problem. So that would be your research problem. If you were writing your dissertation, you will have a section called research problem and then you put it there. If you are doing a paper, you have a section called introduction, and your introduction will include your research background, your research problem, your research purpose, sometimes a summary of your findings, and then your paper outline, all put together under introduction. Okay, in about 2 or 3 paragraphs. For a dissertation, you have a chapter heading, say chapter 1, Chapter 1 is called Introduction. So you put it there. And then you would also see you have subsections. 1.1 will be introduction, sorry, research background. 1.2 will be research problem. 1.3 will be research purpose. 1.4 will be research objectives. 1.5 will be research questions or hypothesis, depending on the kind of study you are doing. And then 1.6 will be research significance. 1.7 will be chapter outline. Okay. So I'll put up, there's a template in the research workbook which you can refer to very easily to know or to identify these various sections. When you follow the prompts to you to be easily you easily identify the various sections I've spoken about. So the next section after your research problem is your hypothesis. Hypothesis we mentioned when we're talking about deduction. People who use hypothesis have in mind that have in mind a theory they already want to test. So they formulate hypothesis based on the theory and then they go out to test it. In a later section, we'll look at how to formulate research hypothesis. Then you have a research purpose. What is the broad aim for your research? In the mobile money fraud scenario, maybe you want to, the purpose of your study is to explain how mobile money fraud occurs. This is a very broad statement that directs us to what your research is about. If you write your research purpose in a research paper, it is enough. It is enough to do that. For a dissertation, you state the purpose, but still go on to write objectives. You break down your research purpose into specific objectives. So if you take the purpose of explaining how mobile money fraud occurs, you can have an objective A, for instance, that explores the nature of mobile money fraud. Then objective B, to explain how victims get defrauded using mobile money. And then objective C could be to explain the impact of mobile money fraud on victims, for instance. So these three objectives all link to explaining how mobile money fraud occurs. Okay. Typically, after your research objectives, you turn it, your research objectives are statements. Okay, so you can turn it, this is the crude form of doing research questions. You just turn your research objectives round into interrogative form and then you have your research questions. And when you read your research question, you should see relationship, all your variables in your work. I forgot to mention when we're talking about the topics that your topic should have two types of variables, one dependent variable and one independent variable. Remember, I said that you should identify a human activity. So a human activity like like fraud. Fraud is a human activity or a human problem. Okay, and then you are bringing in machine learning to prevent fraud. So here, the fraud is your dependent variable, and the machine learning algorithm is your independent variable because there is a machine learning algorithm that is going to affect whether the fraud occurs or not. So it's advisable that you have these two types of variables in your topic. So you can have a topic like how mach- how machine learning prevents mobile money fraud. Okay, how prevention of mobile money fraud using machine learning algorithms. This is a topic and it has both your dependent variable and your independent variable. This for IS researchers. For IT research, Typically, you can have the name of your solution or your system as your topic. So let's say a machine learning based algorithm for preventing mobile money fraud. So when you read the topic, you easily see that this topic is going to present a solution based on machine learning to solve mobile money fraud. Okay. So how do you write research? I have hinted earlier about this issue. So I said that for when you are doing a dissertation, all the things you have spoken about, research background, problem objectives, questions or hypothesis, research significance, and then chapter outline will be shown like this and will come under chapter 1, which is the introductory chapter. But for a research paper, all these subheadings will be subsumed under the first section of the research paper, which is introduction. You can see that there are other sections there, section 2, 3, 4, 5, 6, 7. All these ones may have subsections under them. But right now we are talking about from research background to chapter outline, which will be summarized into about 500 to 700 words under introduction for a research paper. So let's look at some of the tools we can use for our research. The first tool I want to talk about is Mendeley. Mendeley is for doing referencing. So when I showed the slide on induction, you saw that I had cited some people, Kovacs and Spence, 2005. So that's a citation. When you are working on your research, you have to refer to other people who have done something related to your work. And you can easily use Mendeley to do that citation. It will generate your reference list for you at the end of your work, and it will track your references for you. If you make any changes or corrections, Mendeley will track it for you and even arrange your reference list in alphabetical order. Well, some people choose to do this manually. They will copy the references into a text file, um, Microsoft Notepad or any text editor, and then later on produce the list manually. I have come to learn to use Mendeley, and it works well for me. Some people also use Zotero, and Microsoft Word I know also has an inbuilt citation manager, but I prefer to use Mendeley. Okay, so I encourage you to try Mendeley. You can easily download it from the URL provided. And if you are in a country whose first language is not English, like me, I've studied English as a foreign language. I suggest that you use the tool Grammarly. Grammarly is a free tool. There is a paid version based on subscription anyway. I use the premium version. But you can start using the free version. If it is okay for you, you can upgrade later on. So the free version corrects basic grammar and spelling mistakes, which you should avoid if you want to communicate your research clearly. Oftentimes, when I'm reading student papers, I see some grammar and typos, and your mind goes off the substance of the work, unfortunately, to correcting spelling mistakes and grammar mistakes. So before you submit your work, put it through Grammarly and correct all these mistakes. The next tool is Turnitin. Turnitin helps to check plagiarism, that you haven't copied and pasted people's work and presented it as yours. Okay, we've heard of some top politicians who have used other people's work without giving them reference or giving them credit for producing that work earlier. It is unacceptable in academic circles to use somebody's work as yours. So we are going to use Turnitin. I've set up the classes already. Before you submit any assignment, please pass it through Turnitin and ensure that your similarity index is 10% or lower. The institutional threshold is 20%, but we will start working with 10% so that by the time you finish the paper, maybe you would come to the 20%. But let's start at a very low threshold so that as you build on more content in your work, your plagiarism threshold will be increasing and you will not go beyond the 20% which the institution allows. So you check your Google Classroom for instructions on how to check your work in for plagiarism using Turnitin. So Google Classroom is a platform that we'll be using to share materials and also to receive and mark assignments for you to also see your marks. So you can either send me an email or use the code I've showed 4CIK7BA. You download Google Classroom first, then click on Join Class. When you click on Join Class, you'll be prompted to enter the code shown here. When you enter the code, you join the class and then you can have access to all the materials. So these are some references. These are the references I have cited in this lesson or this lecture, first lecture. In summary, we have learned today in this lesson the need for research. We have seen that research helps to explain phenomena. Research helps us to understand what is happening around us. For us in ICT and IS research, we're interested in explaining how IT affects us or how we can build new ICTs to solve human problems. And we have seen that we can approach problem solving or phenomenon explanation using either induction or deduction. We have also gone through the processes for doing research. We said that you should first identify a human issue, which is your dependent variable, and then you identify a solution or an ICT that is already in use, which will be your independent variable. Out of that, you read what previous people have done about the issue to identify your research problem. After your research problem, you formulate research purpose, objectives, and questions or hypotheses, which we will speak about later on. And then you write about it in a research report or a research paper. If it's a research report for a dissertation, you will have subheadings for research background, research problem, research purpose, objectives, questions, and significance, and then chapter outline. But all these come under the first section of a research paper, which is introduction. Okay. So if you have any questions, feel free to send me an email on josbudu@gimpa.edu.gh or budson@gmail.com. You can also send me WhatsApp on 0541003884. Remember to download materials and templates and the ultimate research handbook from www.researchcoa.ch www.researchcoa.ch. This is where I sign off. This has been Joseph Budu, your research coach. Thank you.